This is further loci, and we are going to discuss the locus of P if a point P moves such that Px is equal to Py. So we have to tell what is the locus of P then. So now we going to understand what does this equation mean. Px is equal to Py. As the point P is the moving point, so it will move on that locus which we are going to find. So P is basically a locus. So the distance of this locus from X and distance of this locus from Y is equal. So from the knowledge of basic loci, we know that so locus which is equidistant from X and Y is basically perpendicular bisector. So this blue line is the path of motion of point P, and this is the locus of point P, and P is moving on this line. So when P is moving on this line, its distance from X and its distance from Y is equal. So this is the information which is given in this equation. Px and Py is equal. So wherever is P on this blue line, its distance from X and Y will always be equal. Now the second part, if P moves such that Px is less than Py, this is an inequality. Now we have to tell what is the locus of P when this inequality is given. Whenever inequality is given, first we have to convert this into equation and then try to understand that equation first. So if we convert this into equation, it is Px is equal to Py. So from the first question we understand what does this mean. It means that the locus which is equidistant from two fixed points, that is X and Y, is equal, and in this case it is perpendicular bisector. Now come to this inequality now. Now we have understand that if it is equal, it means that the locus, the point P is on this perpendicular bisector. The point P is moving on this blue line. So this is the required locus when it is Px is equal to Py. Now come to this one. If Px is less than Py, what does this mean? So in this way it means that P is moving in that region where distance of P from X is less than the distance of P from Y. Suppose the point P is here. Point P is moving on this region, and this is the point here. Now if we draw the distance line from P to X and P to Y, you can see here if the distance of Px is less than the distance of Py. And here this inequality tells us that Px is less than Py. So it means that when Px is less than Py, the point P is also in this region. It is on the left hand side of the perpendicular bisector. So if the point P is on the left hand side of this blue line, its distance from X will always be less than the distance from the Y. Therefore, from here we understand that if it is inequality like this, then it says that the distance of X is equal to distance of P from X is equal to distance of P from Y as well. The distance of P from X is also less than the distance from P from Y. So there are two conditions. So it means that P can also be on this blue line, and when we take inequality, that is Px is less than Py, in this it means that P will also be in the region of left hand side of this perpendicular bisector. Therefore, the locus of P is this blue line and the region on the left hand side of this blue line. So the P will move on this blue line as well as anywhere in this region. Now the third case, if P moves such that Px is less than Py. So what is the locus of P? So whenever there is an inequality, first we have to understand that what does equation mean. So we know that the locus of P from x and the locus of P from y is equal. So when locus of point P is equidistant or from two fixed points, it is perpendicular bisector. But in this inequality, there is no equal sign. So it means that the point P is not moving on this line, this blue line. So therefore, this blue line that is perpendicular bisector is not the required locus. So that's why this line is broken line, because this broken line means that this is not the required locus of P. The locus of P is in such a way that distance of P from x and distance of P from y, the distance of P from x is less than the distance of P from y. So if P is on the left hand side of this perpendicular bisector, its distance from x is always less than the distance from y. Therefore, the locus of this condition is that region which is on the left hand side of this perpendicular bisector. Hence, the required locus of in this question, in this inequality, is the left hand side of the perpendicular bisector. And in this case, this perpendicular bisector is not the part of that locus. It is not the part of the region of that locus. So this is broken line. This question sometimes can be asked like this: find the locus of point P such that P is nearer to x than y. So in this region, P will be nearer to x than y. So this can also be asked like this: